Hello students, welcome to Engineers Academy. Kindly subscribe my channel for such more problem solutions. Now we are going to solve this particular problem from chapter 6, that is the friction topic. So in this problem it is said that the 50 kg wheel rolls on its hub up the circular incline under the action of 12 kg cylinder attached to a cord around the rim. So here we have a 12 kg cylinder which is attached to the cord and it is wound around this rim, right? And it is said that determine the angle theta at which the wheel comes to rest, assuming that the friction is sufficient to prevent slippage. What is the minimum coefficient of friction which will permit this position to be reached with no slipping, right? So first we have to determine that theta for which this cylinder will come to rest, right? For which this whole circular wheel will come to rest, right? And then we have to find mu s, the minimum coefficient of friction between the contact surface of this hub and this circular incline, right? So we have to determine this. So now for this problem, this will be our free body diagram, right? And here we have that theta which is required, right? So first of all, this wheel has a weight of 50 kg, so that weight will be acting vertically downward somewhere here, right? And that will pass through the center of this wheel, and this weight will be 50 into 9.81. And similarly we will have that tension in the cord, right? That will be acting vertically downward, and this will be equal to the weight of that cylinder, which is 12 into 9.81. And similarly, since the wheel will be rolling in the clockwise direction, so then here we will have the friction which will be acting upward like this, right? So here we will have that friction force which will be acting like this. If this hub is in contact with this circular incline, so we will have that normal force here like this, and let's say this is represented by N, right? So then this friction force will be equal to mu s N, right? And let's say that the contact point of the hub and the circular incline is, let's say, represented by point C, right? So now as we can see that this weight is parallel to this vertical line, right? So if this angle is theta, then this angle is also theta. So we can resolve this weight into its components, right? So we will have one component of this weight which will be acting in this direction, and it will have one component which will be acting in this direction like this. So this one will be the cos component and this one will be the sine component, right? So I will write that this one is 50 into 9.81 sine of theta. So now if we apply the summation of moment about this contact point, right? If I apply the summation of moment about that point C equals to 0. So now as we can see that this friction force, this mu s N and this normal force, they are passing to that point C, so they will not produce the moment about that point C. Similarly, this cos component of this weight is passing through that point C, so it will not produce the moment about that point C. So only this component, this sine component of the weight and this tension in the cord will produce the moment about that point C, right? So now as we can see that this weight, this sine component is perpendicular with this line, right? So this sine component is producing the counterclockwise moment about that point C. So I will write plus, and this will be 50 into 9.81 sine of theta, and the perpendicular distance between this component and this point C is the radius of this hub, and the radius of this hub is given, right, which is the 75 mm, right? So 75 mm divided by 1000 will be equal to 0.075 meters, right? So we will multiply this with 0.075, and this is in meters, remember, right? And similarly, this tension in the cord is producing the clockwise moment about that point C, right? And if I draw a line here, right? So I will write that this is plus, it is producing clockwise moment, so we will write minus, and this will be 12 into 9.81, and the perpendicular distance of this force from that point C is this much distance. Let me represent it. If I draw a perpendicular onto this line, right? So let's say that this intersection point is C dash, and let's say that this point is, let's say, P. So the perpendicular distance of, or the moment arm of this weight on this tension from that point C is this C dash P, right? This C dash P. So I have to multiply this with C dash P, and this will be equal to 0. So now we have to determine this C dash P. So if I draw this triangle, we have this small triangle, right? We have this small triangle like this. This is that center point. Let's say we represent it by O. So this is that center point, this is that C dash, and this is that point C. So we have to find this distance, right? And we have to find this C dash P. So OP length is how much? So OP length is the radius of this larger wheel, right, which is 200 mm. So this means that OP dash is 0.2 meters. 200 divided by 1000 is 0.2 meters, right? And this OC is the radius of this hub, which is 0.075 meters. And as we can see that if this is theta, then this angle is theta as well, right? So this angle is theta. Both of these angles are alternate angles, right? So we can see that this is 0.075 sine of theta, right? So now we are interested to find this C dash P. So we can say that OC dash plus C dash P is equal to OP, which is, and OP is 0.2, and we are interested to find this C dash P. So C dash P is 0.2 minus OC dash, and we can write that C dash P is 0.2 minus OC dash is this thing, right? This is 0.075 sine of theta, right? So now I can write this equation like this. So this will be 50 into 9.81 sine of theta into 0.075 minus 12 into 9.81, and C dash P is equal to 0.2 minus 0.075 is 0.075 sine of theta, and this will be equal to 0. So now if we divide this whole equation by 9.81, so it will be cancelled out and we will be left with this equation, right? Now we can further simplify this equation, and if I multiply this 50 with 0.075, so we will get 3.75. So this will be 3.75 sine of theta, 12 into 0.2, so this gives us 2.4, right? So I will write minus 2.4, and then 12 into minus plus, and 12 into 0.075, so 12 into 0.075, so this gives us 0.9 sine of theta, 0.9 sine of theta. We can bring this to the other side of equation, so it will become positive, and we will be left with this. So we can take sine of theta common, right? Sine of theta, and 3.75 plus 0.9, right? So 3.75 plus 0.9, this gives us 4.65. So we can write that this is 4.65 sine of theta, and this is equal to 2.4, and sine of theta will be equal to 2.4 divided by 4.65, and we can take sine inverse. So this will give us that theta, right? So sine inverse 2.4 divided by 4.65. So this angle is 31.07. So theta equals to 31.07 degrees. So now when this theta reaches 31.07 degrees, then this wheel will come to rest. Now we are required to find this mu s, right? So if I represent the resultant of this friction force and that normal force, right? So the resultant of both of these will be acting in this direction, right? Since these are the rectangular components of that resultant, right? That resultant reaction force which is offered by this circular incline, right? So let's say if I represent that R, and if I bring this component here, right? And these two are the components of this resultant, right? And this is mu s n, right? And this n is making theta degree here with the resultant, right? This resultant is vertical, right? We have to draw it vertical, right? Like this. It will be vertical is this n is perpendicular to this incline, or if this n is parallel to this line, so then this mu s n is perpendicular to this line, right? So then this r need to be parallel to this line, right? So if it is parallel to this line, so then this means that this r is making theta with that normal force, right? If this is the case, then we can say that if I apply tan theta to this small triangle, right? So we can say that tan theta will be equal to the perpendicular, right? So and the perpendicular is mu s n and the base is n, right? So n will cancel out, so we will be left with mu s equal to tan theta, right? And as we know theta, so that will give us that minimum coefficient of friction which will permit this position to be reached with no slipping, right? So we can say that mu s is equal to tan that 31.07 degrees, tan 31.07 degrees. So that coefficient of friction, minimum coefficient of friction for these two surfaces, right, to keep this wheel in at rest, right? So then that is 0.60. So mu s equals to 0.60. This is the solution of this particular problem. I hope you people would have understood the solution of this particular problem.